Hi everyone. In today's short video, I want to talk about the 50 ohm output impedance of function generators. What we have here are various types of Tektronix, AFGs, or arbitrary function generators. And as you can see here, right at the BNC output terminal, there's this 50 ohm value. And you see that on all of these function generators. So what is this 50 ohm and how does it affect our measurement? So let's go real quick here to the display and look at its simplified circuit of the AFG. So you have your voltage source, your AFG voltage source, and you have your 50 ohm resistor in series of that voltage source. And then you have some kind of load at the output of the AFG. So why do we use a 50 ohm resistor? Well, one of the main reasons is for impedance matching. Impedance matching requires you to have an equal output impedance to your load impedance in order to maximize the power transfer of your signal and to minimize any signal reflection that you might get from your load. And why the 50 ohm load? Because in most RF application, 50 ohm is the most common characteristic impedance that is used. So how does this affect our measurement? How does this affect the voltage at the load? Well, we could simply look at Ohm's law for this, right? We have the equation here. This is a simple voltage divider, so we can know what our voltage load is supposed to be. It would be basically equal to my voltage source times my output impedance, times my load impedance divided by output impedance plus load impedance. From this equation, we could then know what my voltage load might be, right? So we got to make a couple assumptions here. What is my voltage source? We assume it to be, let's say, 2 volt peak to peak, and my output impedance to be 50 ohm. So when my load impedance is 50 ohm, based on this equation, my voltage, my VL, would equal to 1 volt peak to peak, would be half of what the voltage source is. And if my load impedance is greater than 1 mega ohm, or what we call high Z, my VL would then be equal to 2 volt peak to peak, or exactly equal to the voltage source. So let's prove this theory. We could do that real quick here. We have the Tektronix AFG 31000 series. We have it connected to our MS05 oscilloscope here, and we're going to use the oscilloscope as our load. And the nice thing about the scope here, that you could change the input impedance of the scope between 50 ohm and 1 mega ohm. So we could prove this theory. So this would be our load sort of thing. So let's start with the 50 ohm input impedance here. And let's go over here to the AFG, do the setting. This is a nice touchscreen display here that we have. Makes things a lot easier to use. So let's say we want to send a continuous pulse at 1 kilohertz at amplitude of 1 volt peak to peak. Now remember, this amplitude setting is what I want to see at my load. This is not my voltage source that I talked about in the display. 1 volt peak to peak. So let's keep everything in default, and in theory, into 50 ohm, I should see the full 1 volt peak to peak. There, I see 1 volt peak to peak, so my first bullet checks out. Now, if I switch my termination here to 1 mega ohm, then I'll see double the voltage. Then now what I'm really looking at is actually my voltage source. My voltage source is going to be equal to my V load. Now a trick here you could do with the function generator is you could set what your load impedance is, right? So if we swipe up the settings here, you could see what load, it assumes 50 ohm. So that's why we see 1 volt peak to peak, where in reality, it's 2 volt. So if I switch this and I say, okay, you know what? My load impedance is high Z. Now this changes to 2 volt peak to peak, and now I see my correct settings. But you always want to make a measurement at your dot. You always want to make sure what your waveform looks like at the dot. So what do you do if you don't have a scope? Well, we have this nice feature here on the AFG 31000. It's called Insta View, or stands for Instantaneous View, which lets you monitor your waveform at your device under test. We're basically looking at the reflected signal by the BNC cable right on the AFG, sort of like scope. So let's enable it and take a look. We enable it. All I have to do is check the box to turn on channel 1. Hit OK. So now you hear this relays clicking, and I'm actually looking at actual measurements here. So this is in real time. This is telling me my amplitude is 1.98 volt, even though I'm sending 1 volt peak to peak. But that's because it's reading what my voltage load is. So to prove this in real time, all I have to do is change this back to 50 ohm, and this changes to 0.998, which is about 1 volt. So this is a nice feature here to view or monitor your waveform at the device under test and know whether you have a high Z or a 50 ohm, and know exactly what you're sending to your device under test. Hope this video was helpful for you. Thanks for watching.